Hello everyone. This is our module for hackathon. So first, we read training data and testing data here, and then we uh, mm, we start our engineering. So first, we check the class imbalance. We found that 78% of the lines were not defaulted. 22 percentage of lines defaulted. The dataset habits class imbalance as the proportion of lines that stats equals to 0 is significantly higher than the lines that's equals to 1. And we check the new data. There's no new data. So we use the box plot to see whether have the outliers or not. So the box plot of the person income uh, shows the few extreme values extend far beyond the uh, typical income range. Then we'll create the matrix, correlation matrix. Um, apply we apply one hot encoding to categorical features in both DF and DF test. Then ensures that the DF test has the same columns. And we um, perform binding on person age, converting numerical numerical age value into categorical variables. Uh, for example, young and mid-age, and so on. And apply one hot encoding to make the data suitable for machine learning model. And we create the three new features. One, debate to a debit to income ratio, um, annual income per years and employment, and loan interest burden. So after we create these three features, it will improve our prediction of our machine learn. Yeah. And we use standard scalar to standardize numerical features, the z-score, in ensuring the data has the mean of the 0 and the standard deviation of 1. Standardization helps improve the model's stability. And after we splitting the data sets, we use the multi to address the class imbalance problem, improving the model's ability to learn from the imbalanced data. And we drop the duplicators and so on.
Yes, so then we come to the classifiers part. First, we ran a random forest classifier, and we also extract the feature importance from the trained random forest classifier model and sort them in descending order to determine which features have the greatest impact on predicting loan status. We found that the loan default history is the most important factor, while age group has minimal impact. And we also have generate a visualization of it. And we found that the F1 score for the random forest model is around 0.919, which is already pretty good. But we also ran PyCaret to check other models, and we found that LightGBM and XGBoost model also have good performance. So later we will check them. And first, let's have a look at the light GBM model. We found that the F1 score is 0.99, which is extremely high. So this indicates that my model may be overfitting. So we perform cross-validation to access the fit of the classifier. And after the cross-validation, the model is tested on 5 folds each time, resulting in an average F1 score of 0.93, which better reflects the model's generalization ability. For the XG Boost model, we applied the same steps, and then we had a average F1 score after cross-validation, which is around 0.9337. And we found that the XGB demonstrate better model generalization ability during cross-validation. Also, we checked the learning curve for this model, and we found that the high training score, which is close to 1, while a little bit lower validation score, which is around 0.94, indicates that the model is a little bit overlearned during the training set. Then we create a confusion matrix and a precision recall curve. And we found that the overall precision of the model is high, which is around 0.95, meaning that the model's predictions of loan approvals are mostly correct. However, 299 customers with good credits were denied. Actually, this should be approved. So this requires further improvement in recall. And then we adjust the decision threshold to 0.8 to balance the risk and maximize the practical value. But the adjusted F1 score is around 0.9324, which is similar as before. And we also try the hyperparameter tuning, and because we want to improve the XGB model's performance and prevent overfitting. However, the F1 score after tuning is lower than the initial one. So this indicates that my original XGB model is already very good. And then we try to delete the 5 least important features. However, the F1 score also remained unchanged. And it is possible that XGB has ignored the unimportant features. So finally, we choose our final model as the initial XGB model. So that's all for our coding part. Thank you.